Welcome back to another video from the Math Doc. We're continuing with our linear equation set of videos, and we're focusing in this week more and more on geometrical problems. You'll see a lot of these in tests and homework, and so it's a good idea to practice how to use linear equation tools to solve for various geometry problems. We started already with the triangle angle problems, and usually there what we're looking at is situations where we have a triangle and with angles, say 1, 2, and 3. And one of the things we know then is that the sum of all these, the measures of all these angles, so measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. So we used that in the previous video, and there's a link to that video in the description below. If you want to check out, there are also the videos that are the background for solving linear equations, and all that is in the description below. So if you haven't seen those, I suggest taking a look. If you're new to this channel, please subscribe. And let's look today at some problems that are a little bit more complicated than just and include a little bit more geometry than just the sum of angles. And I'll draw another problem here. Bear with my drawing abilities that are not great in any way. So what I drew here is basically two triangles that are head to head. They're sort of constructed from the junction of two straight lines. So we have two straight lines that intersect right there, and we use them to build two triangles. And the important thing here is that in addition to the sum of angles, there's another piece of geometric information that we know, and that is we call the angles that are formed by these two lines, we call them vertical pairs. And vertical pairs, my pen just went out for a moment. So vertical pairs are the pairs that are across. So we have one vertical pair here, and we have another vertical pair right there. So one vertical pair, say, will be given by the angles 1 and 2, and the other by angles 3 and 4. And what we know about vertical pairs is that the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 3 is equal to the measure of angle 4. Again, that's because these are vertical pairs. So we'll use these two pieces of information, the sum equaling 180 and the vertical pairs, to solve a problem that involves the values, the measures of these angles. And we will give that the measures in terms of a variable x. So again, we have x as our variable, and it is measured in angle units, in degrees. And in this problem, this angle here is 3 times x. The other angle on the bottom here is 2 times x plus 10. The angle up here on the left on the top is x plus 40. And the final angle here is just 38 degrees. So let me write this one a little more clearly. It's x plus 40 degrees, and this one here is 2 times x plus 10 degrees. So now we have these two pieces of information, and we'll use them together in order to find x. So our goal is to find x, right? Solve for x, but also use this to calculate all angles. Okay, now what I suggest to do in this case, and there are a few different ways of doing it, but is using the information that the measure of angle 1 equals the measure of angle 2. Now we don't know what angles 1 and 2 are equal to, but we do know something. We know that they're part of triangles, and we can use that information. So how do we do this? Well, let's look at angle 1 first. Angle 1 is part of the triangle that I will highlight in red. And we know that because it's part of that triangle, we know that angle 1, the measure of angle 1, plus 3 times x plus 2 times x plus 10 equals 180 degrees, right? We know that because it's the sum of the 3 angles of a triangle. And so we know that about a triangle. Now, what can we do about that? Let's try to isolate the value for the measure of angle 1. How do we do that? We use our subtraction property, okay? Remember, the subtraction property of equalities is that we can subtract the same number or the same variable or term from both sides of the equality. So if we do that, what we would like to do is we would like to move this entire piece here to the other side. How do we do that? Well, let's take a few intermediary steps. First of all, let's combine these like terms. We have 3x's and 2x's. We don't know what x is, but we know that it's the same x, so this is equal to 5 times x, right? So how about we take this equation, we subtract 5 times x from both sides. Okay, so we get the measure of angle 1. Now we have 5x minus 5x. So we have 0 x's on this side, plus 10, right, equals 180 degrees minus 5x, because we have to subtract the same term from both sides. So we have the measure plus a constant equals a constant and a variable term. Let's take one more step and subtract 10 degrees from both sides of this equality, minus 10 and minus 10. And what we get on the left is just the measure of angle 1. And on the right we have 180 minus 10, which is 170 degrees, minus 5x. Okay, so we have this first value for M1. We can do the exact same thing for the angle 2, and let's highlight our second triangle in green and solve for the second triangle. We know that the measure of angle 2 plus x plus 40 plus 38, these are both degrees, equals 180 degrees. Now, in this case, we can combine these two terms, right? And 40 plus 38 is 78 degrees. So now what we would like to do is subtract x and also subtract 78. Let's try doing this in one step. So let's write minus x minus 78 on both sides, and let's see what we get. Okay, so now on the left we get the measure of angle 2, and we get x and minus x, right? These cancel. We also have 78 minus 78 that also cancel. So we're left with nothing but the measure of angle 2 on the left. On the right we have 180 degrees minus x minus 78 degrees. Okay, this is not too difficult now to simplify a little bit more. So the measure of angle 2 equals, we have 180 minus 78, which is just 102 degrees minus x. Okay, so now we have the values for both our angles, and what we know is that both of them are equal. So I'll remind you, but let's go back up and look at this. Remember that angle 1 and angle 2 are both vertical pairs, and therefore they are equal. So let's go back down here and use that information. So we have M1 equals the measure of angle 2. And now instead of M1, I'm going to write this. I'll write 170 degrees minus 5 times x equals, and instead of measure of angle 2, I'm going to write this, 102 degrees minus x. Now, let's combine like terms. How do we do that? Well, we have to move all the constants to one side and all the variable terms to the other. Let's start by moving this negative 5x to the other side. We do that by using the addition property. Why did we choose to use plus x? Because it's the inverse operation to negative 5x. So we have plus 5 times x plus 5 times x. Let's add these up. We have 170. Now, negative 5x, positive 5x both cancel, equals 102 minus x plus 5x. Now again, we don't know what x is, but we can say that we have 5 of them and we're subtracting 1 of them. So we're left with 4 x's. So we have 170 degrees equals 102 degrees plus 4 times x. Our next step will be to move our 102 degrees here, the constant term, to the left. We do that again by using the inverse operation. We will do minus 102 on both sides. So 170 minus 102 is 68 degrees. That equals 102 and minus 102 cancel, so that equals 4 times x. Okay, one more step. We're multiplying the x here by 4. The inverse operation is to divide by 4, and so we use the division property. Here, we divide both sides by 4 using the fraction symbol, and so we get 68 divided by 4, 68 quarters degrees equals x. Let's do this division problem here on the side. We have 4 goes into 6 once. We get a 4 here. 2, we bring down our 8. 28 divided into 4 7 times. And so our final result is that x equals 17 degrees. Okay, so now we have this result for x, and we can go back and calculate the values of the different angles here. And I'm not going to do all of them, but basically what we can say is, for instance, this angle here is just 3 times 17, which is 51. And this one is 57, right? It's 40 plus 17. This one here is 2 times 17, which is 34, plus 10, which is 44. So we have the different angles, and we can also make sure and check that the results for angle 1 and angle 2 agree, so that our vertical pair here is indeed equal. This will take a little bit of time, and I really suggest that you actually do that, but I won't use our time here on the video to check. So thanks again for joining me on another video. We reviewed some of the geometry of the angles of a triangle and the tools that we use to solve linear equations. And the next few videos will look also at other shapes. We'll look at some area and volume and perimeter questions, so that we can just review together some of those formulas that you can use with linear equations, and you will see on various tests and schoolwork. So thank you again for joining me. If you haven't subscribed, please do. If you have any comments, they are all welcome. And please like, and I'll see you next time.